Let us start today's session. The topic is debugging Linux networking subsystem using procfs. Uh, can you hear me?
Yes.
Okay, thanks. So this procfs is used not only debugging uh, Linux networking, but the Linux system overall. What is the current status? What is the running processes are there? And what are their resources? Those all information can be retrieved through this proc file system. So here is the agenda for today's meeting. Before going into details of this proc and how to use this proc in debugging the networking issues, uh, let us first check what is file system and what is the difference between proc and the other file system. And there is another tool commonly used in debugging, Printk. So what are the disadvantages of Printk and how it is solved by this proc? So again, if you have any question, whenever you have any question, feel free to ask me, interrupt me, and then ask me about that. You don't need to wait for the end of the session. So the file system is actually providing file operations on non-volatile storage of data. That means you are writing something or reading some data from or into the files which are located in one of the storage devices, for example hard drive, USB thumb drive, or SD card, and all that. Every file system has its own way of storing the data. So it has a unique way of storage format that actually differs from one file system to another. And this has two parts. One is the data and the other is the metadata. Data means the actual data which we are writing or reading from the files, and metadata is used to maintain that data properly. As I said, each file system has its own way of maintaining its metadata, and that is how one file system is different from the other. And it supports all the file operations that you can think of: file open, file write, read, file pointer move, and all that. The very famous file system in Linux, at least, are the ext4, ext3, FAT32, NTF, and so on and so forth. There are hundred of file system available in Linux. So I have just picked 4 of them. As you can see in the diagram, that on top of in the user application, there are application which are doing the file operation on the user space are running, and through this they are doing some file operation, and that has been done by the system call. And these file operations are common to every files irrespective of the underlying file system. And to make it common for all the file system, Linux maintain another layer which is called VFS, or virtual file system. And from virtual file system, it actually calls the file operation handler of each of the actual file system, like ext3, ext4, and all that. procfs is not that kind of file system. I will discuss this later. So that is why I intentionally did not put it in this diagram. And then those file system read and write the data from the actual hardware. Any questions? No, this is very introduction section, so I think there'll be much. Okay, so let us move to the next one. Now we use printf in the user space and Printk in the kernel space quite a lot to debug issues. I am assuming that we are debugging software which has been developed by C language, and in the kernel it has to be C language, Linux kernel. But Printk has some issues. For example, particularly when you are debugging any kernel modules or device driver or the kernel, you may not have the source code available to you. So sometimes it is not possible to compile the code and add some Printk into there and then debug the problems. Also, if the source code is available to you, it is not quite easy to compile the code and debug it quickly, because nowadays the source code or the SDK are quite large, and compiling the source code in a comparatively fast computer takes a couple of hours sometimes. So yeah, so it is not possible to, I mean, it's not easy to just add some Printk and then compile the image and then debug the problem. So Printk usually, I'm not sure if you all are aware of this fact, that Printk actually make an impact on the overall performance. Actually the overall speed of the system, whether it's a network or read write or anything else, the performance get impacted. And sometimes, most interestingly, this Printk solve the problem for the time being. So while debugging the issue, you add some Printk into the code, and then suddenly you figure out that the problem is not occurring anymore. So that actually creates the problem, and create a problem in finding out the root cause of the problem. Why so? Because for example, say you are sending some packet and receiving the packet into parallel thread, and then you are getting a problem that after sometimes your receiving thread is not getting the packet in correct order. Some packets are missing. Now, while adding some Printk in the receiving path, you suddenly check that okay, every packet is now receiving. Or adding some Printk in the sending path, now you figure out that all the packets are getting received. So why suddenly the problem gets resolved? It is because there is some timing issue. So the way you are sending is the speed you are at which you are sending the packet is quite high than the speed at which you are receiving the packet. Now, adding the print in the sending path actually delaying the send process. As a result, you are now have more time to receive the packet properly. So yeah, sometimes this Printk suppresses the actual issue. So it is not always possible to use Printk in debugging the software problem. On the other hand, there are some way to query the system when it is required. You ask the system what is the current status, and you can know or you can get the corresponding information. That query the system can be done. There are two very famous way of doing that in Linux system. One is IOCTL, and the second one is the procfs. Any query?
Hello.
Hello.
Saravana this side.
Hi.
See, this is my first session. So
Okay.
I guess I'm missing a lot. Why don't even know what the Printk is. So I couldn't get it discussed.
Sorry, I didn't get your point.
Yes, may I know what Printk is?
Oh, Printk. Are you familiar with printf in the C language?
Yeah.
Yeah. So printf is used in the user space program.
Okay.
which are running in the user application,
Mhm.
you can think Printk is the corresponding version of which you can use in the kernel program or in the kernel space.
Okay.
There are some difference between printf and Printk, but for the time being, you can think is the Printk is the kernel version of the printf.
Okay.
I just want to point out the minor in the title of the slide. It says there's a typo. There's a T missing in the disadvantage of Printk. There's a T missing.
Yes, thank you for that. I will okay. Modify it. Thank you.
Yeah.
Yes. Okay. So now what is Proc? Proc is provides a technique to get the information not only from the kernel space but from the kernel modules as also. Means it is not necessary to think that you are getting the information only from the kernel or only from the kernel modules. No, you are getting information from the kernel space. So whether it's the kernel itself or some other subsystem or kernel modules and all that, you can get information through Proc, provided that particular subsystem is giving information to Proc. Otherwise, it is not possible. So that is the only prerequisite of this thing. So this Proc is a special software created file system. You can think is as a pseudo file system, or you can call it as a virtual file system, because this has nothing to do with the actual file system. I will later explain about it in details. And the main purpose of having Proc file system in Linux or in Unix-based environment is to have a way to communicate between user space and kernel space program. That is the main purpose of doing the procfs. There are multiple files, multiple information available in the Proc. For example, what is the current status of the memory that you can check through the Proc mem info. What is the current status of means what are the modules that has been loaded currently in the system that you can check through the Proc modules. What is the CPU frequency? What is the how many numbers of ports are there? That you can also check through the Proc CPU info. And there are a lot more information that you can check. Overall system wise, every process wise, all the information are available in the Proc. So what is the difference between procfs and the other file system? As I said, Proc is a virtual file system or pseudo file system which has nothing to do with the actual files, and definitely here data is not stored in the non-volatile memory. So that means across the reboot, data is not available. Whenever the system boot up, the data in the Proc is getting generated by the kernel modules or the kernel subsystem, and those are visible in the Proc. So it is not stored permanently. And as there is no file, there is no data or metadata kind of concept. So that means Proc does not have to maintain any data storage format like other file system does. And another point is usually file system are independent of operating system. That means they have their own data storage format, but that is independent of the operating system. If the operating system support that file system, then that file system can be used in that particular operating system. For example, ext3 and ext4, although these are used in the Linux and not used in the Windows platform, but if we can develop or implement the file system by following the data storage format of ext3 and ext4, then ext3 and ext4 can be supported in the Windows as well. But on the other hand, Proc is usually not available in all the operating system. It is mainly used in Linux-based operating system.
So I have a question. So
Yes.
the proc file system, the size of the proc file system cannot exceed the available RAM,
Correct.
right? I mean,
Right.
okay, yeah. I mean,
And actually, not the full. Proc is not using the full RAM. It is using a partial size of the RAM. So
right.
So yes, it has the dependency on the size of the RAM of your system.
Right. So I mean, it is not possible to swap part of the proc file system to a hard disk.
No, usually not.
Okay.
So how a proc file system will be useful to learn the things? So if it's not having a traditional file systems features, then how are we going to achieve, if suppose even if I wanted to use this proc for my current projects or something, so how would that be useful? Like
Yeah,
it's not a
that I am trying to provide in this session. So please stay with me. Then possibly I will answer a few of your queries. Is how Proc can be useful in not only debugging the system, to knowing the system, what is going on in your system, that you can also know through the Proc.
So the major advantage is that we can see the modules and then status of the modules and then the memory usage. So that is the use of
No.
proc.
That is only a very small part of procfs. I will show you multiple examples of how Proc can be used to check the system and check the debugging the networking section.
Fine, thanks.
I will show you.
Yeah, sure, thanks.
Yes. So the size of the proc file system, does it limit the number of processes in the given system?
Yes, it can. It can.
Okay.
Through Proc, actually, you can configure the system, provided the system is allowing you to do so. There are let me go through that. I will show you. Proc has three main criteria. One is to check the current system, monitor the system. One. Two is to configure the system to some extent. It's not possible to configure everything through Proc. Third is to debug the system. It's not only the networking. Networking is the primary object in this session, but through Proc you can debug other section also. Okay, I'll show you. So for example, this is the output of the Proc mem info. I'm taking the partial output of the mem info. There are a lot of information. All the information are also not, I do not understand everything because not all are not needed to me. But you can see that what is the current total memory of your RAM. Please note that this is the total memory of RAM, not the hard disks or any non-volatile memory. And out of this, how many is free, how many is available, what is the and how many bytes are cached and all that. So for example, if you are particularly this is useful in debugging in on embedded system where the resource is very limited. In the PC desktop, resources are quite large, so you don't need to debug whether the resources are getting exhausted or not. But it is quite normal to check the things in the resource level in an embedded system. So there, say you have developed a C program where you are actually allocating memory randomly, or I would say in an unplanned way. In an unplanned way means you are allocating memory whenever it is required, but you are not conscious enough to free those resources whenever you are not using it anymore. As a result, what happens? It will gradually consume the memory of your RAM, and suddenly, at one point of time, the system will reboot because there will be no RAM or there will be no free available memory in the RAM. Now, debugging those kind of problem is useful if you continuously check the current status of the proc info or proc main info file. So if you are on a different terminal, periodically running this cat command, cat proc main info, and checking the memory free things, then you can understand, okay, someone is consuming memory much faster than it normally has. So from those, you can understand, okay, someone is there. Now, if you stop your program and then you suddenly check that, okay, the memory consumption is now stopped or is not at that speed like it was in earlier. So from that, you can understand, okay, so now my program is not written very well, or the software that I am running is not developed or not designed in proper way, and there are some memory leaks. So then you can check the code or use some other tools available in the Linux and debug the problem. Similarly, what is the route information of your system? That you can check through the proc net route information. There are multiple information available in the proc net. I will show you while in my laptop, but I've just taken a few screenshots from my devices. Here is one example, is the cat proc net route. So what is the route information available in your system? Similarly, the second one is proc net NF connection track. This NF connection track means it will list down all the network connection that has gone through your system. So that means your device is not the end device of those connections, but your device is acting as a router where some device is connected to another interface of your device. So what are the sessions that is currently there? What are the connection that is there? That you can check through this NF connection tracking. As you can see, there are ISMP protocol, TCP protocol, UDP protocol, and all that. Even in the TCP protocol, what is the current state machine of that TCP session, that you can also know, like it is in the established state or it is in the timer state. Those kind of information, the source port, destination port, IP address, and all that, those all information can be known through this NF connection track file. So those are the example of monitoring the system. There are tons of files there. If I'm going to show you every file, then it will itself takes a 3-hour session. So I've just picked a couple of files from them. Similarly, you can configure the files. So if you want to configure the files or debug the files, then there is one directory called /proc/sys, under which you can not only monitor the values, you can configure the values or you can change the values. For example, if you are familiar with the Printk, Printk has different log level, starting from kernel critical, kernel error, kernel info, kernel debug, and all that. So that means if you are writing a program using Printk, and there you are supplying the label as, say, print debug, that means you want to know the output of that Printk line when you are debugging the system. Otherwise, it is not required. That is your current purpose. But on the other hand, if you set the log label as kernel error, that means these messages are very important. So whenever that error path occurs, it should print the line. So that means in your program, there could be multiple Printk whose log level are different. Now, by default, as you can see, if I if I check the current log level of the Printk, that is the 4. That means the log level whose values are in between 0 to 4 would be visible in the console. Others will not be visible because those are debug messages or information messages that you are not interested currently because the system is now running quite okay. So you don't need to debug those messages, or you don't need to see the messages, because as I said earlier, that adding more Printk will make an impact on the performance. So you don't need to slow down your system unnecessarily. So you don't need to see the debug message by default. But now, at some point of time, let's say you are facing some issues in your modules or in a network modules, and now you want to know what is the current means why such problem is occurring. So for that, you may want to know more information from the kernel. At that time, you can enable the debug level, and then kernel will start printing the debug log level also in the console. How we can do that? You can set the Printk level as 7, which is the maximum level. You can set the Printk level as 7 and then set it in the Printk file. Now, if you can check again the current value of the Printk, now it is 7. So that means now all the log level of Printk will be visible in the console. Got my point?
Yeah, but I have a question. What is this 4417?
Those 3 others values have different meaning. We don't need to bother about at this moment. We only need to bother about the first one, the first column, that is 4, or then I change it as 7. So that is the current log level.
Okay.
So I have a question,
Hmm.
if you're done. So yeah, so when we discuss first, Printk would, we understand that, Printk will definitely have an impact on the performance. But
Yes.
so I thought, we will, with a proxy, we might see some kind of substitute for the Printk, but we're still using the Printk. But how are we going to,
No, I'm
is there
not.
any?
I'm not using the Printk. Yeah, it is a mechanism. I'm just showing you a mechanism through which you can configure the system. So if you still prefer that you are going to use the Printk, because it may happen that you do not have any other debugging tool. For example, you do not have any hardware debugging tool, or the system where you are running if in a particular embedded system, maybe you do not have all the debugging tools that you used to have in the PC. So in that case, you will still prefer to use the Printk. I would still recommend you not to use Printk blindly. Okay, because Printk will definitely slow down the performance. But on the other hand, in a situation where you do not have any other choice other than using the Printk, this is the way you can at least selectively on and off the Printk whenever it is required. So if you are printing every message all the time, that means the debugging messages are also coming up in your system. That means it will make a more impact on the performance. But on the other hand, if you want to suppress the debug level messages or the unnecessary messages, only the error messages will be there. There will be no other messages. So you can configure your system accordingly using the Proc. So that is my point. But yes, I would still prefer to use other debugging tool than Printk.
Right. So when you're saying other debugging tool, it is that, Proc will provide us a better way of debugging the things,
No, Proc will give you more information about the system.
not any. Okay. All right. Got it.
Okay, so for example, I'll give you some example of during means what I faced in my career while executing the project. Then you can understand what it means, how Proc will be helpful in debugging the problem. But yes, but you please do not think that Proc is a replacement of the Printk tool. No, it's not like that.
Okay. Yeah, that'd be better. Yeah. So.
Yeah.
Yeah, one more question. So
Mhm.
here, let's say we enabled Printk to the highest level, let's say 7 it is.
Mhm.
And the logging level, as it increases, the file size also the log file
Yes.
also will increase, right? So
Yes.
what is the, I mean, does the logs roll over, or like how is it?
Usually
What is the
logs
maximum
roll
size you
over.
can put?
Usually logs
Okay.
roll over.
Okay.
Usually every log system is a rotating type, circular buffer type.
Okay. And what is the maximum
Otherwise that will
size
itself
you came across?
consume the memory. Yes, please.
What is the maximum size of the log file at an instance that can
That
store?
you can configure also.
Okay. Okay. Got it. Okay. Yeah.
So how is it getting
It
filed?
comes up with a default value, but you can configure also.
Sorry for the interruption. So how that log file is getting filed? So when we reaches a particular, size of the memory, so how would how it would get a file, because it is like you just said that, in the proc environment, it's everything is virtual. So I hope the log files will also be in the virtual memory, right? So when you are pushing that,
No, you are confusing in two ways. Log is not of the proc.
oh, okay.
Log is for the kernel.
Mhm.
Usually logs are not stored in the non-volatile memory, but you can. It's up to you. You can redirect that. Means in the kernel log level, you can call it as a D message. There is a command called D message, DMESG. We call it as a D message. So through D message, you can check the kernel log. Okay.
Okay.
And that usually stored in RAM, not in the non-volatile memory.
So, okay, for
But
an right. Sorry to interrupt here, because most of our cases, so it will be like, so issue will happen. We'll have to go and see the things like for an example, very next day. So when we post process the things, so it absolutely need that doc files to be there in our non-volatile memories in it. So
okay.
it
So
has to
you
go back
can
and see. Yeah.
then redirect that.
Okay.
You can if you are debugging any kernel system, kernel modules, then you can redirect the modules to a particular file using some shell script or any cron job, something like that.
Okay. Okay. So it is that, the proc will be very much useful on a online applications status and other the usage of it.
Yes,
Them,
yes,
right?
yes.
Okay. Okay.
But
Okay.
yes, using the proc, you can inform the other modules that you can store the log file there. You can increase the log level. You can fine tune the system. Like the second example I'm showing here is that the IP forward file, correct?
Right.
This IP forward is actually used if you are checking this particular file in your system where the system is behaving as the end device. That means it will either receive the packet or send the packet, but it will not forward the packet. That is not the job it usually does. Your PC or your laptop or your phone, correct? So in that case, this IP forward, the value of this IP forward file is 0. So that means you are instructing your kernel network module that you do not need to forward any packet. So that will immediately improve the performance, because in the networking domain, in the networking model, particularly in the IP layer, so whenever it receives a packet, it will check whether the packet is destined for my machine or not. Correct? That is the first checking it does. Now, suppose the packet is not destined for your machine. Then the second task it tries to do is to check if it can forward the packet to other networks by using other interface of your system. So, but if your system is not capable of doing that, then checking that forwarding path is unnecessary in your system. But if you make it enable, or if it is enable all the time, then it will unnecessarily make an impact on the performance of the network stack as well as of the overall system from the network point of view. Correct?
Yeah, right. Yeah.
So that we can disable based on the usage of that particular Linux machine. If I know that this Linux box, whether it's a PC or embedded device or anything else, I know the usage of this device is the end device. It's not a router, or it has nothing to do with forwarding the packet. Then I will always set this value as 0. On the other hand, if I want to configure my PC as router, I have two interfaces in my PC. One is wireless and one is the Ethernet, and I want to forward the packet from Ethernet to wireless and wireless Ethernet. In that case, I need to forward the packet from one interface to another in the IP layer. Means I need to do the routing if I want to do that. So that I can do by setting this value to 1.
Okay. Okay.
So this is the way you can configure the system.
I mean, we can even do this with other applications, right?
Yes, yes,
right?
but all the these are very simple things you can do.
Okay. Okay.
Because the method is very simple, right?
Right. Right. It's quite
You just need to
straightforward.
write a 1 or 0 or something like that.
Right. Right. Thanks.
Any questions?
See, can we enable the IP forward permanently?
For that, you need to modify the code or compile the code accordingly. By default, it is always 0. Or you can do that. You can do is in the booting script. Okay, that after booting, it will you write this command from a script, which will be executed during booting time.
Got it.
That you can do.
Yeah, it can be done to sysctl.
Yes.
Yeah, it can be enabled. Yeah.
There is a command called sysctl through which you can do that.
That is system controls one, or?
Yes.
Okay.
That actually takes these proxies. That is why this is called sys.
A small request. So whenever you people are discussing about these things, no. So if you could elaborate a bit, would be really helpful. For an example, like CTL. So it would be better for us to know, like, okay, it's a system control. While booting up the things, we can even modify the system's behavior. So those things would also help a lot. So it's a kind of
Okay.
yeah.
Okay.
Thanks.
So shall I move forward? Yeah. So in this session, in this particular topic, I do not have any slide to show you. Rather than I have few examples that I personally did while execute the project in my career. I'm telling you two stories. I've already told you one story about the memory that actually I faced in my career, and at that time procfs was very useful to find out the problem. On the other hand, I actually been working in the industry for last 17 years in the embedded networking domain. So most of my work are in the embedded domain rather than on the desktop PC, where the resources are very limited. So I need to always think about that. So one of my project was to port one application from PC environment to an embedded environment, like Nginx kind of thing. You may all know about the Nginx. It's a heavyweight web browser, currently very famous in server areas. So, so before running them on the embedded system, I used to run them on the PC, and those are things are running quite fine, no problem at all. Then while start running them on the embedded device, initially it starts working fine, but say when we start running the while we are running it on the embedded system for say 8 hours at a stretch, then we suddenly figure out that that particular component is no more working. Now, what was the job of that particular module? It was actually a server which was receiving TCP connection from multiple clients simultaneously and provide service. As you can see as an Nginx. So Nginx is a web browser, so it is providing the web pages that you can check from multiple client machines. So yes, initially it was working fine and then suddenly stops. So now we are after going through the code and debugging, we figure out that after sometimes, after quite a lot, I mean 8 hours or so, any more socket creation is getting failed. Okay, and that is now very complex issue to debug, particularly if you are running on in the user space and you do not have much more knowledge about the kernel internals. And also debugging the issue by going through the Linux networking stat code is not very straightforward to do so, particularly when you are not very hands-on experience on the Linux network stack. So what you are thinking is that you are running the socket and you are getting -1. Socket creation itself is getting failed. So at that time, what we do, for example, let me show you my system.
So you exhausted all the file handles?
Yes.
Okay, I also face this issue.
Yeah. So what happens actually, we creating the socket. Once the service is done, we forget to close the socket in a particular path. It's not that we are not closing any socket. In 90% cases, in 90% use cases, we're actually closing the files. But in a particular case, there we are actually not closing the files. So that is why it was not, the issue was not simulated very quickly. It takes 8 hours or 10 hours, and sending TCP client request for continuously in that 10 hours, then only this issue is getting simulated, otherwise not, because those corner cases is getting hit and those sockets are not getting freed up. As a result, we are consuming all the sockets that is currently available in the system. For example, now what we can check through the Proc, this is the current process numbers that are running in the Proc in your system. So for example, say I am preparing a file. say AVI daemon. This is the PID is 6872. Now 6872. 6872. Okay. So that means if you want to know the information about the AVI daemon, you can check that PID and corresponding information in the proc PID file. Here, sorry, you need to have the super user permission. So then you can check the number of information in your system for that particular process ID. So for example, if you want to check the how many files are now currently used by the 6872, you can see that 1, 2, 3, 4, 5, 6, around 10 to 12 sockets are now getting used by this 6872 PID or the process. So what we noticed during the debugging of our program is that say currently 10 TCP clients are connected to our servers, and maybe we are maintaining 2 more sockets for the maintenance, internal maintenance. So that means we are expecting that 12 sockets will be open at that time, but we are seeing that 100 sockets are there. That means something is wrong. So number of simultaneous connection at that time is not matching with the number of socket is currently used by our process. So those kind of information you can check from this proc information, and then you can debug. So you can understand that yes, the proc is not like Printk. Proc will not provide the information that means proc will not help you in debugging the method that you are going to use by Printk. But on the other hand, proc will provide you enough information to find out the root cause of your problem. Now, after this, you can use the Printk to check whether, or you can go through the code, review the code, or use some other tools that why my socket is not getting closed, whether that path is not executed, or I'm getting any error and all that. That you can that you can debug further. But proc will definitely give you a clear picture of where is the root cause. So in that way, procfs is very helpful.
Yeah, suppose say, I mean, just this is this is one more scenario. Let's say you have a memory leaks, and at the end of 8 hours, and the system rebooted, and then you'll have tough time, right? Figuring out it is a socket issue or the memory leak, because the proc system is created at the boot up. Everything is gone.
Correct.
So how do you,
so in
I
that
mean,
case,
do you
so
have
if
any,
you are, see, if your system is rebooting, there could be multiple cause for that. One is definitely RAM is totally full. That is why the system is rebooted. Or one of your code system is crashed. So in that case, you will see at least some hex dump or code dump kind of thing, or panic kind of thing. Then you can check that it is rebooted. Otherwise, usually your memory is getting exhausted. Usually, to double check it or to verify that your hypothesis about the memory exhaustion is correct or not, you need to run another process or another program which will continuously check this cat proc memin for information. And
some kind of watchdog program which will have
and it will dump somewhere else in a non-volatile memory, so that after reboot you can check the condition whether it is gradually decreasing or not, and where it's getting rebooted, at that time maybe it's very close to 0.
Yeah, exactly. We did the same thing actually.
Yeah. These are very standard way, but if you do not face those kind of issues, then it is very difficult. Once you know how to debug that, then it's very straightforward. So I'm just trying to say whatever experience I had during my last 17 years, so that your debugging method could be faster or could be easier.
Yeah, thanks a lot for sharing your experience here.
Yeah. There could be other reasons also for which, say, your bind is not working, bind API in the socket, or the connect API is not working. It may happen that the number of free ports available is also consumed. So maybe by default in the embedded system, you have limited the number of ports which can be used when you are connecting to the server or to the client, actually to the server. So if we, so again, by debugging that info or by checking that information in the proc will be helpful to check whether you are now out of resource in the network system or not. Accordingly, you can fine tune the system and then you can fix the issue. So what I'm trying to say is that usually if the problem means the root cause is definitely in your program, but currently you are getting issue from the system, not from your program. Like socket API is getting failed, bind API is getting failed, connect API is getting failed. These are usually you think that, okay, system is not working at this moment. Now, why system is not working? At that point of time, you can check the proc and figure out why this system is behaving erroneous, whether the resource is getting exhausted or some other socket is already, say, see the bind is getting failed is quite popular if another program is running on the same port number, correct? So say if you are running two server program which you are listening on the same port, then definitely in the second program the bind API will fail. It will say that the someone is now used by the some port is getting used by the another program. Now, how you can check that? You can check that what I show you in the NF track. Here, that what are the connection is getting used in your program and what are the process is running in there, whether that is there any process which is listening on, say, port number 1, 2, 3, 4, which you are planning to use. So that way you can debug your system. Otherwise, if it is a feature-wise failure, then procfs may not be useful because this is a particular feature of your program, and if it is just not working, then your logic or maybe your design is not correct. But on the other hand, if system is giving you an error, then it is always difficult to find out, and at that time procfs is very useful. There are tons of information available in the proc, not only about the one of the common problem that we used to have is in an embedded device or even in the Linux PC, you have plugged in your USB thumb drive, and that thumb drive is not mounted. You cannot access the file. What is the problem? Either the USB thumb drive is problematic, means the hardware has some issues, which is very unlikely or which is very rare. On the other hand, the mount is getting failed. Now, how you can check that whether the mount is getting failed or not? For example, you have formatted the USB thumb drive using, say, NTFS file system, and the Linux system that you are using, their NTFS is not supported. In that case, that file system will never be mounted. So what you can do, you can either install the NTFS if that is available as a kernel module, or you can recompile the kernel with enabling the NTFS, and then the problem will be solved. So those all information is available in the Proc. It's not only about the networking. In the networking, you can check there are a lot of information. In the sys, you can not only check, but you can configure the system. As I said, not only about the IPv4, IPv6, net filter. Net filter is one of is where you can check the network related information. It is in my system. It is not there because it is the end device. So net filter is not have any role here. But if it is a router kind of device, then net filter has a lot of information which you can configure, fine tuning. Sometimes you can fine tune it to improve the performance also. Any questions at this moment?
See, I have a question.
Yes.
See, actually, you told we can check out the which file, 1 minute, that contract enough underscore contract file, whether the another application is listening to the same port.
Yes.
Then, so can you go there again and explain? I couldn't get when you said.
Okay. So let me show you another example. You're talking about this one, right?
Yeah, this one only.
Yeah. So, for example, see, if this is one way of doing that, there are some other way also to which you can check whether any process is listening on the same port. For example, there is a tool called netstat, NETSTAT, netstat. So this netstat, these kind of tools are actually getting the value from the proc. For example, I'm just going out of your question. For example, ARP, there's a ARP command, right? Which will show you the ARP table of your C system. But actually what it does, it actually gets the data from the proc net ARP file and populate in a way to which you can mean it is more visible or more useful to you. Because as you can see in the route information, this is also similar information that you can see to the route command. Let me show you, and then I will get back to your question, definitely.
Okay.
Let me show you. So if you run route -n, you will see 3 entries, right?
Yes.
And it is more readable to you because this has been mentioned in a IP address way. The table is more readable, more formatted. On the other hand, you can check the same information from here. Actually, what this route application does, it actually read the file this procnet route and populating the values in a more readable format, nothing else.
Okay.
So similarly, there are some application called netstat, which actually shows what are the program currently running on which port it is listening. But on the other hand, you can check this proc net NF connection tag, provided you are running it on a router environment. It's not in the end PC, Linux PC environment. So there you can see, if I explain three entries here. The first entry is IPv4. There's an ICMP connection is going on, where the source IP address is 1.10, the destination is 13.127, something like that, and yeah, this is the ID, and number of packets is so far is 0. Similarly, if you check that TCP connection, that means, say for example, you are running an application on port number 443, which is the HTTPS protocol, correct?
Yeah.
So, and you are assuming that there was no server running in your system. So in that case, bind will not fail. But on the other hand, if there is a server running in your system, then on the same port, then your program, the bind will fail. Now here you can check that there is one entry which is using this destination port as 443. That means someone is running, or some program is listening on port number 443, and that is why your bind program is getting failed.
Okay, got it.
Any more questions so far? No. Okay. So then, as I told you earlier, is that
I'm sorry. I have a question. Can you please go back to the NF contract?
Yes.
So there's a destination port 443. That is the local port on the system, right? I mean,
this is the no. In this case, this is not the local port. I have taken this from a router device. This is not the output of my device. So here, okay, the connection is made through my device, where the end device is running on 443.
Okay. So no, but the dump you got of this NF contract is so there's on this machine you have web server running on port 443. I mean, you have a SSL.
No. That may happen, or that means one application on port 443 may run or may not run. But what this particular entry is showing is that one session has been established between source IP 172.130.55.121 and 13.232 and 211. There is being a session, a connection has been established where the port number is 443, destination port. That means the server which is listening on 443, it is on the 211 main machine.
Oh,
and,
so this,
and the 121 IP is the client machine.
So the 121 IP is the IP address of the local machine from where
yes.
Okay. So, but here on this entry, the source and destination IP address are switched. Is it why is that? I mean, initially
you can change it. Means this means whenever you are connecting to the server, a TCP session is getting established, and that entry is getting created. Means that is getting added here. This NF contract connection track file.
Yeah. Okay.
But it has to be router. Otherwise, not. If it is end device, then no.
Okay. All right. Okay. Thanks.
So as I said earlier that if you want to get information from the kernel module also needs to create proc file for its subsystem. Otherwise, you do not have any way to get the information from the kernel driver or kernel subsystem, anything. So for that, if you are developing a kernel module, whether this is a driver or any other subsystem in the kernel, and if you want to share some information with the user space using proc, then you need to write some code in the kernel module so that those information will be available in the user space. To do that, you first need to add or create a file in the /proc. You can do that by an API called proc_create. Please note that these APIs are only available in the kernel. It's not available in the user space. Means user space cannot create any proc file. It can only use the proc file. Whether it can read the proc file or write the proc or write into that particular proc file if that is allowed in the by the corresponding kernel subsystem. As an example here, I am planning to create a file called dummy dev, and I am planning to provide both read and write permission, as I'm putting it as 6.6. So I'm planning to provide both read and write permission on that particular proc file. So once this line is getting executed in the kernel or in the kernel module, a corresponding file will be created in the /proc, as you can see here. A dummy dev is getting created. Okay, and now I am providing another argument here is the pointer of a structure myops. I will show you in the later section. Similarly, if you want to remove the proc entry, you can do it by an API called proc_remove. You need to use the same handler which is being returned at the time of proc create. So ENT, this is the same variable I am using in the proc remove API. Now this my ops, there are mainly two handlers, read and write, but these two are optional. I mean, it is not necessary to provide both the read and write. It may happen that you are not allowing user to configure your system. Those are the files that you can see is the procnet or proc mem_info. This proc mem_info file, write is not allowed. Only read is allowed. So in that case, if the write is not allowed, in that case you can write .write is equal to null. That means write handler is visible. Here in my example, both the read and write handler are enabled. And before going into this slide, let me show you the code so that it will give you more insight. I have added this information in a dummy network driver. I earlier prepared a network dummy driver which was not connected to any particular device, but the job of that network driver is to receive the packet from the network stack, loop back it in the driver itself, and send it back to the application. That was the role of this network driver. And now there I added a proc entry. Here you can see I have created a proc entry, the same line that I showed in the PPT, and similarly remove entry. One thing need to notice I will ask you if anyone of you answer me, is that I write the proc create file at the end of the init module. But on the other hand, I write the proc remove line at the beginning of the cleanup module. Is it necessary or the order is anything else? Any idea? Means the order is important, that the proc create should be at the end of the init module and the proc remove should be at the beginning of the cleanup module, or it can be anywhere else. What do you think?
Because I mean, first we have to register, right, and then we have to create the proc entry.
Yes,
and then,
correct. But if I execute this line at the beginning, will there be any problem? Suppose I write it here. Will there be any problem?
because we have not registered. It'll since it is not registered with the kernel, the proc entry creation will fail.
No, you are very close, but not fully.
Okay, I mean,
no problem.
Okay.
What does this init one does? Dummy init one?
This actually create a network interface in the network stack.
Okay.
It's a driver initialization routing. You forget about this one because you don't need to understand this one. This is a driver initialization routine. It is a network driver, so it is actually initialize the network part. If it is a character driver, then it will do the character related part, or if it is something else, not driver, if it is something other kernel module, so it will does its own job. Why the proc is at the end, and why proc is at the beginning in the cleanup module? This is important. See, the API will not restrict you to means it is not mandatory that you cannot write the proc create at the beginning of the init module. It will work, not a problem. Position is not important here. But on the other hand, from the design perspective, you must understand that proc is to debug your system, right? Debug your kernel module, whatever the role of this kernel module has. So unless your kernel module is initialized properly, there's no point of providing an interface to the user space to debug with your kernel subsystem. Say, for example, you execute, you write this line here, and for some reason, this initialization code fails. Either the link register is failed or this dummy init one is failed. So at that time, you need to again remove this line in the out function because your driver is not initialized successfully. That means no point in providing an interface to the user space. Correct? So that is why these lines are usually at the end of your initialization module to ensure that your driver is initialized or the actual job of the driver is initialized and then successfully, and then you are providing an interface to the user space, to the proc. That is point number one. The second point is, whenever you are executing this proc create, then the dummy dev will be created immediately. That means you are allowing the user to start interacting with your kernel subsystem. Now, it may happen that you are still busy in doing some other important job in the kernel module of your initialization module. Here, For example, you are still doing some initialization code in the dummy init one. And as a result, you do not want user to start interacting with you. So it is always necessary, or it's better, I would say, to provide the interface when you are done with your initiation part or when you complete your job internally, and then you are exposing yourself to the users. That is why I intentionally put this proc create at the end of the init module. Is clear, or have any question here? I guess clear. Okay. So now next, why I am putting the line at the beginning of the cleanup module? Any ideas now? I have provided hint in the initiation section. Any idea?
Like, yeah, it's the same where you don't want the user to immediately interact when he wants to interact. So you wanted to remove as quickly as possible.
Yes.
And then unregister.
Yes, because you are now closing your shop. So you don't want any customer to start interacting with you.
Right, after it is unregistered.
Sorry?
So, I mean, yeah, you don't want the entry to be around when after it has been unregistered, right?
Yes. Because you can see in the shopping mall, okay, it is quite whenever the person who is at the counter, they actually put a notice there that counter is closed. Correct. Collecting whatever the money he has collected, so that he can report it to his manager. So first job he or she has to do is to put a notice at the beginning of his or her counter that this counter is now stopped working. So similarly, you inform your user that this proc is not available now, because I'm not, but for whatever reason, I'm not closing it down, or I'm not taking some rest, something like that. So that is why this proc remove has to be at the beginning, so that you start the line between the user space and kernel space, and then you do your own job to shut down yourself. Clear? So now let us do the check the my ops. As I said, there are two handlers, read and write. In the read handler, there's some interesting information. This read handler, that means you are whenever user program cat the file, this dummy read function will be executed, and at that time you are what you are doing, you are providing the information from the kernel space to the user space. For example, if I check, I'm not sure my driver is there. Oh, already there, so this is fine. So that means the file is there. Yes. So now if I can see the values of two variables. Is up to the driver or up to the kernel subsystem that what are the information that it wants to share with users. I'm just providing two random things, random variables, and showing it here. It has no importance. The value has no importance. But what I'm trying to explain here is that I want to show the current value of the IRQ and mode. So that means user space will provide a buffer, and in that buffer, I need to copy the value of IRQ and mode. I can do that using this API called copy to user, because the why this is required, can't I just write ubuff is equal to buff? Can't I do that? Is there any problem? Is can I use mem copy instead of copy to user? Do you have that concept?
Yeah, because I mean the ubuff it might have been the swapped out, or if what if the process is if it's not a valid pointer, and
No, I am assuming that this is the right one. I'm trusting you. So whatever memory you are giving me, I am assuming that this is valid.
But I mean, if it is swapped out, I mean, if it is
it may happen swapped out, but
then in that case,
is not the point here. The point here is this dummy read is getting executed in the kernel space.
Yeah.
So the IRQ variable and the mode variable are in the kernel space. On the other hand, you are checking those values or you are reading those values in the user space.
Yeah.
And kernel space cannot access the user space memory and vice versa. User space memory cannot access the kernel space. So there has to be a system context switch between user space to kernel space. And that is getting done by copy to user. That means whatever value I have, I am preparing this buffer variable locally, and that is obviously is in the kernel space. And now I am copying this kernel space value of the buffer to the user space value ubuff by an API called copy to user. So it is actually copying the value from the kernel space to user space. Simply mem copy or string copy is not done here.
Yeah, but again, why mem copy will not work?
Because the memory is not available to me. It will not be copied to the user memory. See, it is something like that. Okay, let me, instead of this one, I'm showing you another example. Then it will be more clear to you. Because this is, I'm showing you from the shell command. You can, another point was that this proc dummy dev is a file. So you can open the file using the C program or any program, Java, any other program that you know, and do the file operation. So let me show you that code. Then you can understand it properly. See here. So this is a C program which is running on the user space. So what it does, it actually opens the file and it actually reads from the file. Correct? Now this buffer is definitely in the user space.
Yeah.
And this IRQ or this buff is definitely is in the kernel space.
Right.
So this user space or kernel space cannot be same memory. And more importantly, this kernel space cannot use that particular, because this buff is a virtual memory. It's a virtual address. On the other hand, this is a physical address.
Yeah.
And I do not know what is the corresponding physical address of this virtual address.
So you're saying the kernel will not have access to the page table?
My module does not have that information. Kernel definitely has. Kernel definitely has. That is why this copy to, I am just using the kernel API copy to user, so that internally kernel copy from my buffer to the physical address of this buffer.
Okay.
So that the content will be copied to the actual user space memory.
Okay.
But that memory is not known to me. That memory is only known to the memory management module of the kernel. Correct?
Mhm.
And knowing that information is a bit in for me. I need to do a lot of things for that.
Can you please explain what does internally happen? Copy to user. What does internally happen? Like we passed our buff and how
It
does it
actually
copy?
internally means
At high
see,
level.
I do not remember the exact code, means the implementation of the copy to user. That I need to check and then I can tell you. But theoretically, what I remember so far, it actually this buff is a virtual memory. So this has a corresponding physical memory, say P buff,
Yes, yes.
and that is known to the kernel memory management unit. Okay. So what it does, it whenever I check, I am doing the copy to user to the U buff, it is actually checking the corresponding P buff of this U buff and copy the buff, and then it will automatically reflected in the virtual address of this memory. So while you are developing the kernel module or device driver, you do not need to worry about that, because that is the responsibility of the memory management unit.
Yeah. So
But
this
this has
copy
to
to
be.
user is a standard API or is it written by you?
No,
Is it?
don't. I'm
It's
not.
a
Please.
it's a built-in
This is a built-in kernel API.
built-in
Okay,
kernel.
okay.
If I was
Yeah.
the developer, then I will show you my code. No problem. Similarly, so this is as you can understand that if there is a copy to user, then there will be a counterpart, copy from user. When you want to take the data, take the value from the user space to the kernel space. For example, here I am writing 33 and 4, correct? So that means I am sending some value to the kernel space. Now to get that value from that memory, I need to call copy from user so that I get the value. So this is the right handler. You can understand easily that this is the right handler of the proc file system, which does the copy from user. So it's quite simple to understand that if you are using read handler, then it will do the copy to user. If you are implementing the right handler, then you need to call the copy from user. So that way you will get the value from the user space to the kernel space, and then do whatever you want. So whatever example I have shown you in the PPT, in the proxies, the corresponding network module has to have this kind of similar kind of implementation in their module, where they are actually uh, getting the value by using the copy from user, and then based on the value, it is enabling the IP forwarding mechanism or disabling the IP forwarding mechanism, enabling the log level of Printk, or disabling the or load down the log level of Printk, all that. Now you must visualize the kernel level code that it does in the internally to handle these proc operations.
So question. So in this, when if the user process is swapped out, then this copy from user or copy to user, it will not be able to find the corresponding P buff for
No,
ubuff, right?
that will be handled by the scheduler and the memory manager. That is not the problem of the kernel module. You are talking about
Okay.
about a different level, which is being handled by the other system of the kernel. That will happen
Okay.
always, right? If that was the case, then that can happen in anywhere. Then the system will be at mess.
Yeah.
Yeah. So that will be an atomic operation, or it will use semaphores
Yes,
or
yes,
whatever
yes,
it
yes.
is.
Means, but
It is hectic. Yeah.
it has to
Not our
be
headache.
ensured that this is being copied to the user level. Whether or not, whether it is getting solved, or that particular process is now is in the queue, and a new process is now getting scheduled by the scheduler, that all could happen. But in all cases, this has to be maintained properly. And that is not the responsibility of neither the kernel module, where you are doing the copy from or copy to user, or not the user program, where you are reading or writing the data. Clear? I have nothing to share so far. So whatever information I like to share in this session, I've already done that. If you have any question, we can answer you. Otherwise, we can close the session.
See, should that be particular to this topic?
I will try to answer your question if it is out of this session. If I know, I will definitely answer.
It's just a general question only. So right now, I'm a product support engineer. I'm supporting to an internet load balancer.
Internet load balancing, okay.
So if I want to enter into this kernel network stack development, what is the logical pathway? Another thing is I don't have a bachelor's degree. I hold diploma in computer science, have a 3 to 4 years of experience in IT networking.
You know C programming?
C and Python, yes.
C and Python, you know. I'm assuming that you have a logic sense. Okay.
Okay.
Don't take it personally. I'm just assuming. Okay. So you have a logic
No
sense,
problem.
and you have a you know the system now. Then yeah. See, if you had a bachelor degree on the computer science, then it will be easier or quicker to learn. Otherwise, you need to work hard. But it's not like that. If you do not have bachelor degree, then you cannot learn or you cannot work in the kernel areas.
I'm asking like some companies may have policies, developers should have at least 15 years of full-time degree, those kind of barriers.
Then it's a problem. If the company has any um, prerequisite that you have to have bachelor degree or you have to have 15 years of experience behind you, then I cannot help you. But from the working area, I have worked, as you know, I have worked more than 17 years, and I have communicated with a lot of people. Many of them are from IT, many are from IM. Some of them have bachelor degrees, some of them are not. It's not about the bachelor degree or whatever degree you have. It's about the willingness and the proper planning to do the work and to know the system properly, conceptually. Otherwise, you will be a bigger problem, because knowing something partially, wrongfully, it will add more pain rather than know the things simple in a simple way and in a more conceptual way. Then it will be much easier for you and much quicker for you to learn the things.
See, if so, what will be the prerequisites to join this course? Maybe some Linux courses.
Which particular course you are talking about? Means what particular things you want to learn?
That networking driver development.
Networking driver. Then you must know the networking first. Do you have the basic concept of the networking? Do you have the I'm just asking. So you must ask yourself that Do I know the networking concept? By networking concept, I mean to say IP address, TCP, UDP, port, socket, and all that. Do I have the hands-on experience on the socket programming for TCP, for UDP, for raw socket, and all that? If I do not have, then I must enroll to a session. We are actually planning to do that. So where you have the networking hands-on first on the user space. Do not jump directly into the kernel space.
Okay.
You must know first the user space, and then gradually you must learn into the kernel space. That way it will be easier for you, because in the kernel space, the coding is minimum, but the knowledge requirement is very huge. You need to understand everything. You need to understand this, as I say, you need to understand this scheduling process. You need to understand the memory management process, but you do not need to know every details about how memory unit is working. But you need to at least know the virtual memory, the physical memory. You need to know how the networking stack works, how the driver packet getting interrupted, how this packet sent. So unless you start from the user level, I think it will be difficult for you to work in the kernel level.
Okay.
That is my opinion.
Makes a lot of sense. Thanks for it.
Welcome. Any other questions?
It would be great if you can add some exercises at the end of the presentations for our understanding. Like we will work on those exercises, and it will be more.
Okay.
Yeah, I mean this is just suggestion, but
yeah, definitely. This is a good session. I will discuss internally with our team, and yeah, we'll come up with, and I'll definitely consider your suggestion.
Yeah. And for the Sarvanan, like yours, do you suggest any? I had a background on the system system side, but it's been a long time, like 4 years. I had worked on that, and I wanted to brush up those concepts. And do you suggest any online courses just to have a brief
you can
walk over
check this Linux Kernel Foundation. There are a lot of courses available there, and also some of them are coming in from March or maybe from April about this networking actually. So we are actually planning to have more detailed classes, sessions where we will provide some homework kind of thing that you are suggesting. So hopefully by going through those sessions in details, or you will have more understanding about how to do that.
Yeah. Thank you.
Yeah. Aditya, are you here?
I have a question.
Yes.
Can you please provide the makefile if I want to, let's say if I follow this presentation and I want to create a proc entry by just copying this.
Please, whatever information I share here in my code, these are available in the internet. These are very standard code. So you just need to search procfs entry in kernel module. You will get first 2 or 3 links where you can have the sample code.
Okay.
But most likely this recording will be shared with you. So here also you will know the.
I'm saying the makefile, the makefile to.
Makefile, that is the kernel. Okay, let me show you the makefile.
The makefile to build the .ko.
Okay. So that is a kernel makefile. So for any kernel module, this makefile is common. This is a makefile.
Yeah. Okay.
So these are very standard makefiles of the kernel modules. You can download anywhere from the internet.
Yeah, but I mean, if you could just include it as part of the presentation, I think.
Okay. Okay, I will do that.
Okay, thank you.
Anything else?
Okay. So, are you contributing to this open source Linux kernel development? I mean, just a.
I earlier used to have.
Okay.
And then I used to work. I'm not sure whether you are familiar with OpenWRT. Maybe you have.
Okay.
OpenWRT is one of the open source router framework.
Yeah, I work on OpenWRT.
Okay. So good to know that. So I contributed there. A couple of my patches are available there. So yeah, other than that, I used to work in office. So there's some this I used to do on embedded device, both in the Linux kernel as well as in the applications. So if you have any, if you want to know anything particular in subject that it will be better to have a session or a detailed classes on a particular topic, you can share with us. We will consider those. Not only network internals, but other subject also, if there's any requirement from your side.
So in your classes, do you also teach other drivers like SRIOV driver or USB drivers?
At this moment, there is no planning, but yes, we are in near future actually. We are planning to provide some information starting from the network device driver, then the USB device driver, and maybe Wi-Fi or other device driver based on the demand in the market.
So then in this the network device driver class, are we going to look at some production network device driver like a gigabit or gigabit device driver?
And that requires some hardware. So I do not know about I need to discuss internally, and then I can comment on that. But yeah, it is better to have some device driver session on actual hardware to know the actual complexity of the hardware. But so far, we have prepared the dummy device driver without the hardware. So every device driver has two parts. One is the device driver framework, which is independent of the hardware. So that we are planning to teach you anyway. So which will be required for any hardware, and then the hardware specific information. There is no generic way to do that, but yes, it is better to have one hardware in hand so that we can do some practical work on that.
Right.
Okay, so be in touch with Linux Kernel Foundation. There will be link available. Okay. If there is no more point to discuss, then we can close it down.
Yeah. Thank you again. Thank you once again for sharing your knowledge with us.
Thank you, and thank you for attending the class. It was a nice one.
Thank you.
Thank you. Bye bye.
Thank you, everyone. Yeah.
Bye bye.
Bye.